First talk was about WASM. Who was here for the WASM talk? Anyone? You guys? Anyone else? No? Okay. Well, there are two different topics, but in this talk, I want to talk to you about open standards for building event-driven applications. I've been using event-driven building event-driven applications using event-driven frameworks since the beginning of my career. Actually, one of my first jobs, we were building an event-driven framework for Flex Data Services. I don't know if anyone used it, but we were trying to connect Flex Data Services, Flash applications to Java backends. And there we built an eventing system where you had the consumers, producers, topics and stuff like that. Then after that, I used JMS when I was doing Java. Then after that, I moved to Azure in the cloud, and there were Azure queues and stuff. And then I was working at Skype, so we were building some eventing there. So this event-driven stuff, it's been always around. But one thing that frustrated me is the lack of standards around it, right? With REST and OpenAPI, we had some kind of standards around REST-driven applications. But with event-driven, I feel like there hasn't been that much standard. Everyone kind of did their own thing in their own way, but the concepts were kind of similar, So that's why today I want to talk to you about two open source projects, basically, that will help to bring some standards into this space. The slides on my talk are on speaker deck as usual, so you can get it. And then I also have a repo with my samples, and I'll share the link as we go along. All right, so let's do a little bit of introduction. Oh, by the way, you feel free to ask me questions as we go along because we have enough time. So yeah, feel free to do that. So let's imagine we're building an event-driven kind of architecture. Let's say it's an order processing system, and I'm kind of simplifying it here. But imagine you have a front end that receives the request. So maybe that's a REST call. And then once it does its part, the receiving the order, then it wants to signal to the rest of the system that I received this order. So what it can do is it can send this order received event that includes the information about the order that goes to a message broker or event bus this kind of the backbone of this event-driven system. Then the message broker looks at this event type, and it figures out that the payment processor needs to receive that event. So the payment processor will receive that event, then it will do its part, and then it will send another message type called payment processed, right? So and then this goes on. We have a shipper function, then we have a notifier. But the key point here is that there is a backbone, message broker, and event bus, and there's different services that are totally independent. They don't know about each other. They don't care about each other. They don't call each other directly, but they communicate with events indirectly. And these events are usually different event types, right? So that's a simplified event-driven architecture. Now, in this architecture, you need to decide on a couple of things. First, you need to decide the envelope of these events. So how are these events going to be routed? How do you send them from here to there? There has to be some format there. And the second thing that you need to decide is that, you have these services that are publishing events and that are receiving events. So how do you communicate that? How do you document that, right? So this is what this talk is about. And the summary is that CloudEvents, it's an open source project that we'll talk about. It defines an envelope for your events that you can use. And AsyncAPI, it helps you to document the format of your events. It also documents which services publishes what events and which service subscribes to what events. So it gives you tools to do that. And in the end, I'll show you how to use both. So if you want to use CloudEvents in your services, and if you want to document that using AsyncAPI, how can you do that? And it actually works pretty nicely together. So now let's look at CloudEvents first, and then after that, we'll look into AsyncAPI. Sorry, by the way, the screen is a little bit off-colored because I need to show some stuff later, which is dark. But then now I realize it's too bright, but hopefully it's okay. So first of all, why CloudEvents? Why do we even care about CloudEvents? Now, again, let's imagine our event-driven system. And usually in event-driven systems, you have some event sources that are emitting some events. And then you want to send these events to some event destinations, right? And then there is a middleware somewhere where this routing will happen. And maybe in this middleware, you also want to do some filtering, some enhancement or whatever, right? So it's not just simple routing. Maybe there's more stuff that happens here. Now, if you are using one system with one format, maybe this is not so complicated. But usually what happens is that you probably have event sources publishing events to different kind of environments. So maybe you have a Kafka topic where you send the events to, or maybe you have some IoT devices that are sending events to through MQTT, or maybe you're in the cloud and then you want to have a service to send events to a Google Cloud PubSub topic, right? Now, all of a sudden, your middleware becomes much more complicated because now you need to understand different protocols like Kafka, MQTT, PubSub. You need to understand different formats. So how do events get sent over the wire? Is it JSON format or is it something more efficient like protobuf, or maybe it's Avro? Your events have their schemas, so you need to keep track of that and ideally communicate that so people know what to expect. So the thing is that reading events and routing is difficult, and maybe you have multiple middlewares to handle all of this, right? And how you do this, and is there a standard you can use? Basically, CloudEvents is that standard. It's an open source specification for describing events in a common way, okay? And I'm going to show you examples in the next slide. But it's not only specification, it's also SDKs to read and write these events. So it has SDKs in different languages to also makes this easier to read and write CloudEvents. It does this by defining a minimal set of context attributes. So these attributes, they're the minimal things needed to route your event and nothing more. And then it also gives you a way to send your own custom data. So you have these fields called data or data base64 for base64 data. And that way, you can put anything you want for your application in that data field. So minimal set of attributes for routing and data for your own custom applications. Now, how does a cloud event look like? There are two different formats of cloud events. The first format is called binary mode. And this is good for receivers that might not be aware of cloud events. And I will show you an example, and this will be clear when I show the example. So here, let's look at a curl. So this is an HTTP request that's sending a cloud event in binary mode, okay? And as you see, we have a header. We have some special headers for cloud events. We have some extension attributes, and we have some data. And if you look at them in detail, first the content type defines the type of the cloud event. So in this case, application JSON means that this is a binary mode cloud event. Then you have some required attributes. So these are the minimal set of cloud events headers that you should have. So the spec version is 1.0, the type of the event, the source of the event, and the unique ID of the event, right? So that you have to set these. Then you have some optional headers like the time and the subject. These you can include them if you wish. And finally, you have some extension attributes. Let's say your application has some custom things that you want to send as cloud event headers. You can set them as extension attributes, and they will be read. You can send and read them afterwards later. And then finally, the actual data that you want to send goes in the body. So that's the custom data that you want to send. So this is binary mode cloud event, and I said this is good for receivers who might not be aware of cloud events. Because let's say your receiver doesn't understand cloud events, it can simply ignore the headers and it will have the data still, right? So for that, those kind of events, receivers it's useful. But as you see, like cloud event is nothing but just extra headers that we defined so that we can route these events in a common way. Now, the second type of cloud events is the structured mode. And structured mode allows simple forwarding of the event across multiple routing hops. And I'll explain again what this means. Now, in structured mode, instead of using headers to route the events, we put everything in the body, basically. So as you see, we have a content type again. And in this content type, this time it's cloud events plus JSON is the content type. and that determines the mode, in this case, structured mode. Then we have the required attributes like the spec, type, source, and ID, just like before, but these are not headers now, they're in the body. Then we have the time and the subject like before. Then we have our extension attributes like before. And finally, since everything is in the body, the actual data lives under the data field, right? So here we have our custom data. And again, this is useful if you want to just forward this through different hops, routing hops, because nothing is in the headers. So a router won't drop your message because of some header that it cannot read. Everything is in the body, and because of that, most of the time the routers, they just send the body as is. They don't touch the body. They usually work with the headers. They're both the same though. You can use either one, and in all the SDKs they support both. So there's no reason why you should choose one or the other. It's just a matter of preference, basically. Okay, so we have the formats. What else CloudEvents provide? Well, first of all, the format of the events is JSON by default, but you can use protobuf, Avro, and there's XML, which is in draft. How you send the event over the wire is that by default it's HTTP, but it also supports things like AMQP, Kafka, MQTT, so on and so forth. And WebSocket was in draft last time I looked at it. The SDKs I mentioned, so there are SDKs for pretty much all the major languages. And you also have Cloud Event libraries from vendors, because I told you that the data field includes the actual data, right? And then cloud providers, for example, Google Cloud, they have this Google Cloud Events library to help you to read the data field as well, because that will include the actual event that you're interested in. So you use Cloud Event SDK to read the envelope, and then you use the custom libraries to read the actual data part of the Cloud Event. Of course, there's always some caveats. So for example, there's a batch mode in Cloud Events where you can batch multiple events and send them all at once, but it's not supported in all protocol and SDK combinations. For example, JavaScript SDK supports HTTP and Kafka batch mode, but it doesn't support MQTT batch mode for some reason. Not all event formats are supported in each SDK. For example, again, JavaScript SDK supports JSON, but it doesn't support Avro or protobuf. Not all protocol bindings are supported in each SDK. Again, JavaScript SDK supports HTTP and Kafka, but it doesn't support AMQP, MQTT, and NUTS, right? So what I'm saying here is that there's all these features of Cloud Events, but not all the combinations are supported in each SDK and in each language. So you need to basically, if you are using, for example, Java, you need to go and check what is supported and see if you can do these things. In some cases, yes, and in some cases, no, because it's an open source project with separate SDKs that are also open source, so they all evolve at different rates. And then there's 3 upcoming specs in Cloud Event SDKs. These are not implemented yet, but there's a Discovery API, Subscription API, and Schema Registry. This is all about how do you discover events, how do you subscribe to them, and also how do you describe these events in a registry, which is interesting because what I'm going to talk about next, the AsyncAPI, they also try to do similar things. So in a way, Cloud Events is kind of getting into the space of AsyncAPI. We'll see how that evolves, but these are 3 specs within Cloud Events that are coming up in the next release. And there's, well, you can't see this, but there's basically a bunch of companies supporting Cloud Events. One I will say is that Google Cloud, for example, it has something called EventArc, which is an eventing system that uses Cloud Event as its eventing format. Adobe has their I/O events using Cloud Events. And then there's Azure, for example, has Event Grid that's using Cloud Events. So there's quite a bit of support now, and all the vendors they're trying to support Cloud Events because it makes sense. Once you have this common format, why not use that instead of using your own format? Okay, and just to show you quickly how this looks like. For example, I have this. I know this is a Java conference, but I will show you an example in C#, which looks quite similar. Let me. So if you go to, I have this repo that I'll share later. So I have an example to show how to read CloudEvents. And if you are using Java, this should look similar. But basically, here I'm using the Cloud Native CloudEvents SDK, and then I am listening on port 8080 locally. And then here I receive a request, and I just read that using the SDK. So here we are just reading the cloud event envelope. And the way you do this in Java, it depends on what framework you use, like Spring and others. They all have their own libraries to do this kind of things, but the idea is similar. And then the other one I mentioned, like once you read the event, you want also to read what's within that event. And here I have an example of a Google storage event wrapped into a cloud event. So if you look at that one thing you'll realize is that there is this Google Events library that I'm using. And then what I do here is I create a formatter that says this is a cloud event, but it has the type of storage object data, which means a Google Cloud Storage event. And then when I get the requests, I just call toCloudEvent async and then pass the formatter. And this basically extracts the cloud event for me, but it also extracts the data field. So the cloud event data has the type storage object data. So that way I have strong type of the event, the cloud event, but I also have the strong type of the data field of that cloud event as storage object data. So this is the actual event that I'm interested in. And this is the cloud event that's the envelope around that event. And for Java as well, this is pretty much not the same, but similar kind of concepts. And the libraries that you use will be Java specific. Okay. Okay, so I talked about this. So for the envelope, basically what I'm saying is that cloud event it's an envelope that you can use, and it's becoming more popular. So I think you should look into that. But then we still need to talk about which service publishes what events and how you can subscribe to them and how can we document that. So for that, we have AsyncAPI. AsyncAPI, it's an open source specification to define an async APIs, similar to what OpenAPI does for REST APIs, right? So we had OpenAPI for a while for REST, and basically AsyncAPI, it's its cousin to document event-driven services, basically. But it's not only a specification, it's also tools to visualize. So once you have the specification, you can use some tools to visualize that. And then you can use tools to validate the definition, make sure that it's a valid specification. And then you even have generators to generate code from that specification. And these generators, they're in different languages and they support different kind of formats. So again, not all the combinations are supported, but at least there's basic support to generate some code from it. So what are the main concepts in AsyncAPI? Well, these are the main things that you need to know. At the top level, you have an application. So that's your event-driven application. Underneath, you have a server. And typically, you have multiple servers. Like you might have a production server, testing server, staging server, stuff like that. Then for each server, you have channels. So how do you talk to that server? And then the channel will have a protocol. So maybe HTTP, maybe something else. Then finally, you have producers and consumers to send messages to and receive messages from these channels. And then you have messages, the actual things that you send to the channel and their formats as well. Okay, and I'm going to show you an example of this shortly. And finally, you also have bindings. So bindings allow you to extend AsyncAPI for your own custom protocol. So you can extend server, channel, operation, and messages to add your own custom things. For example, Google Cloud has bindings for Google Cloud PubSub. That way, you can use AsyncAPI to document Google Cloud PubSub topics, basically. And I'll show you some examples of this shortly. I know this is very difficult to see, but one question I get is that, what's the difference between OpenAPI and AsyncAPI? And the difference is basically OpenAPI, it's for REST APIs. And because of that, it has paths, right? It's path-based. And then under path, it's hard to see, but under path, you have operations, and these operations are get, put, post, the usual HTTP operations, right? So that's how OpenAPI is usually, the paths and the operations under the HTTP operations under that. Whereas AsyncAPI is for event-driven. So instead of paths, you still have servers, but you define channels. So that's the thing where you send messages to. Then under channel, you have operations, but operations are much more limited in AsyncAPI. The operation is either subscribe or the other publish, right? So you can either publish messages or you can subscribe messages from the channel, and that's it. And then what you send to that channel is the message. So you also need to define the message there. And the rest is pretty much the same, right? So instead of path-based, it's basically channel-based. And instead of sending operations with HTTP operations, you send messages that you define. And I'll show an example shortly. So that's the difference, but they both try to do similar things, but with different constructs, because it's different, basically. Like REST and message-driven is quite different. So how does an async API definition look like? So this is the simplest async definition that you can have. By the way, this shows 2.6 async API, but now 3.0 just came out, I think. So I need to update these, but it should be pretty similar. So what we are saying here is that this is async API 2.6, and this is our application, a little bit information about the application, the title and the version. And then we define a channel, and then the channel has a name, hello, and then it has an operation, publish. And then what you can publish to that channel is a message, okay? And then this message has a payload that has type string. So this basically says, I have a channel that I can publish a message to, and this message has only one string in it. So it's the simplest thing that you can have. Now, if you look at a more complicated example, so this was hello world 1, but let's look at a slightly more complicated one. So in this case, we are defining a server, and this server, it's an AMQP protocol server, okay? And then under here, we have channels. We have two channels. The first channel is hello, and we are saying that we can publish this message, but we are saying that this message is defined under here. It's a hello message, and we're going to define that later, right? So we can publish a message. It's a hello message, but we'll define that later. Similarly, we have another channel, goodbye. We can publish a message, and this is a goodbye message that we will define later. And then under components, you will define what these messages should look like. So we are defining components and messages, and we are defining what hello message is. And here we are saying that this hello message has a payload of type object. So it's an object. And then the object has two properties, name, which is string, and then it also has send at, which is defined under component schema send at. So we'll look at that later. And then similarly, the goodbye message has a payload of object, and it only has send at as its payload. And then if you look at under send at, it's basically a string, and the format is a datetime. So it's a datetime string, right? So you see here how we are defining our channel. We are defining what you can publish to that channel, and then we are defining what kind of message you can publish to, and with all the details, basically. So if someone looks at this, they can exactly tell what they can publish and how, and we can actually visualize this too, that I'm going to show you shortly. So that's the async definition, async API definition. Now, at this point, you might be wondering, like, what does it mean to publish and subscribe operate? What does it mean, like, to have publish and subscribe under channels? Because it can be confusing. It can be confusing because you need to know which, like, depending on whose perspective you're looking at, it can be confusing. And what I mean by this is that, in async API, you have publish and subscribe. So from server perspective, this means the server receives the message, right? And then from the subscribe means the server publishes the message, okay? But from user's perspective, publish means the user publishes messages to the server, and then the subscribe means the user subscribes to receive messages from the server. Okay, and then in WebSocket, if you are used to WebSocket terms, publish is more like send, and subscribe is more like receive, right? So because of these perspectives and different terms, it can be confusing. But I think the user's perspective is the most useful one to think about. So if you are thinking from the user's perspective, publish becomes basically the user publishes a message to the server, and subscribe becomes the user subscribe to that channel to receive messages. So just think of it that way, and then you won't get confused. And actually, I have this example. Maybe we can go through this quickly. So let's say you have an account service publishing a message, user signed up, it goes to a message broker, and then from the message broker, that message gets routed to an email service, right? Something simple. So how do you define this in AsyncAPI? Again, you need to think about from the user's perspective. So from account service, for example, is it subscribe or publish, do you think? Because it's publishing. So let's take a look. So account service, we define our channels, and actually it's subscribe because a user subscribe to receive that message from the service, right? So yeah, the service is publishing, but user is subscribing to receive that message. So that's why it's subscribe. And then so we define this as subscribe, and then we define the message, what it is with its schema and all that. But then if we think about email service, is it publish or subscribe? Subscribe. Okay, so let's take a look. Email service. So this is, oh, sorry. Yeah, this is email service. Well, email service is published, right? Because you publish to that service that message as a user. As a user, you publish that to the email service, right? Because when you look at this, email service like receive that, so that means you need to publish it as a user to that thing, right? So it can be confusing, as you see, and that's why I try to think about the user's perspective. So this is how I define account service, and as you see, like the messages and the schemas are the same, and then if you look at the email service, everything is the same except this part, the channel, and the messages and schemas is the same. And actually, what you can do in AsyncAPI, that's the cool thing, is that you can combine these common parts into a common YAML. So here I'm defining a common YAML that defines the messages in a common way and the schemas of those messages. And then what I can do is that in my account service, I can simply refer to so I'm referring to my common YAML servers, and then I'm referring to my common messages. That way, I have a central place for definitions, but I can refer to them from different parts of my application, and that's pretty useful for me. Yeah. Yeah. Right. Well, we don't know from this picture what email service. Yeah, maybe, but email service doesn't know anything about that. Emails, all we know from this diagram is that account service publishes an event, and then, yeah, exactly. Yeah, so that way, but then when you think about the user's perspective, the user is it publishing or receiving, subscribing a message from account service? It's subscribing because the user will receive that. And then in this case, is email service, do you receive? So from a user's perspective, do you publish or subscribe? You publish to it, right? So that's why this is publish and this is subscribe. Right. Right. Yes. Yeah, it's true in that sense. But REST is much easier to think about, I would say. So it's always one way, right? You always put something to the server, where in this case, the service are publishing and another one receiving. So that's when it becomes confusing, because then from whose perspective you're talking about? From the service's perspective or from the user's perspective? And my argument is, I mean, this is an area that I think AsyncAPI did a little bit of poor job, because it's always confusing. But I feel like if you just think of the user's perspective, then it kind of makes sense, you know? All right. How much time we have, by the way? 15 more minutes, right? Okay. So the tools I want to mention. So once you have the spec and once you have figured it out, there's an Async Studio to visualize this, and I'll show you an example of this. There's an AsyncAPI CLI it's a CLI-based tool to work with AsyncAPI files to validate them and to generate. And it works with generator to generate code from it. So these are the tools around AsyncAPI that makes it easier, you know, to visualize, to validate, and to generate code. And let me just show you an example of this. Let me double check. I forgot how much time we have. So we have 15 minutes. Okay. So I think I have some time. What I want to show is, let's say I had my account service from before. Let's copy that. And this is the Async API Studio. You can run it locally, or you can also use it in the browser. If I show it here, see, I paste it here, and then you can see that it gives me this visualization. It tells me my servers, then it tells me the operations on that server. So there's a subscribe operation, and then it tells me what the payload should look like. So display name and email. And then it even gives me an example of display name and email. And then it shows me the messages. And I can, well, I think it links to something else. But you get the idea here that it basically gives me a nice visualization of the spec. And I think this is very useful when you are documenting your services, so people can look at it and say, okay, this is what I can do with this. Another one is the AsyncAPI tool, but I don't think I have time to show that. But let me see if I can show something quickly. This repo, by the way, has a lot of examples, so maybe if you want to look, you can check later. But so I want to show this quick start. So you can install this AsyncAPI CLI, and then you can install the generators. So this is Node.js based. And then you can install MQTT protocol, because that's what we'll be doing to test it. But then what you can do, this is the CLI tool. You can create a new YAML file for your application, and it has some sample applications. So this one of them is streetlights, and then after that you can visualize it like I showed you. But then the cool thing is that you can validate that Async API. So if you write something and you want to validate and make sure that it's a valid one, you can use Async API validate. And then finally, you can generate code from it. So for example, in here, we are linking to streetlights YAML, and then we are using a template, in this case, Node.js template, and passing the server name. And with this, you basically have a Node.js application running. So you can go to streetlights, it generates the code, and then you can start, and then you can use MQTT to publish a message to it, and then it will work. The code generated is not the greatest code, and also the code generated is not, for example, for Java, there's a Spring-based generator. It generates some code, but I couldn't get it running for some reason, because I probably don't have the Java environment set up here. So what I'm saying is that the generators are community efforts to give you some code to play with, but I wouldn't use them as like the production kind of thing. Like, I think you still need to generate your own service code. But for testing, I think it can be useful to have this starter codes to kind of start playing with it. And there's an example you can go through to set that up. Okay. Okay, so we got the envelope, and then we got async API to kind of document what service publishes or subscribes to what events. But now I think the one question I receive is that what about CloudEvents and async API? Like, can I use them both? And also, I also wanted to see, this is all good. Async API is all good because it's an open source project. But what about something real like Google Cloud PubSub I use? Can I use async API to document that? And the answer to both is yes. And that's, I think, really shows the flexibility of async API. So for example, can I use CloudEvents and async API together? The answer is yes. And I want to show you quickly how this works. So let's imagine you have a service that publishes CloudEvents in binary format or structured format, and you want to document it using async API. Let's look at the structured one first. So remember, in structured one, all the headers, CloudEvent headers and the data are in the body, right? So how can you document something like this using async API? And I will show you the definition. And in this definition, you see that we create our channel, and then we say to this channel, you can publish a message of this type, and then we can come to this message, and then we can see that this message has headers, and the header is application CloudEvents plus JSON. So that's the header that we should have for structured CloudEvents. And the payload is this user sign-up payload, right? And if you look at under this payload, the first thing that we'll realize is that this payload, it has to have this, we are referring to CloudEvent spec. So CloudEvent has a published spec. So I'm just referring to that. And what this does is that it basically says this CloudEvent, this message has to have this CloudEvent headers. And if you look at this spec, you'll see that it's basically all the things that CloudEvent define, like the spec version type, data content type, all that stuff, right? So we are just referring to that. And by doing that, we have our CloudEvent documented. And actually, one of the things that I really like is that if I take this and then put in Async Studio, then I see my operation, I see my payload, and then I see an example, right? The data and the ID and all that given to me from Async API. And this really clarifies what kind of things I can send to this endpoint. Okay, and then the other one, in binary mode, remember in the binary mode, the CloudEvents were they were defined in the headers. So how can we define this using Async API? Again, Async API has something called message traits. And message traits are the headers that you should have for each message, basically. So you can define these as message traits, and then you can use them afterwards. So what I did in here is that first I defined, this is something I had to define because CloudEvents didn't have this. So I defined this CloudEvent headers, and then I'm just saying these are the required ones, and then there's some optional ones. So I just defined them in GitHub. And then once I have that, if I look at my binary, in binary, when I define my message, I'm saying that, okay, in this message, I need to have these traits, and these traits are coming from my own GitHub repo that I defined, right? And the payload is going to be just the body of my message. So that way, I'm requiring that all the messages, they have their header, and we are good to go. And if I copy this again to Async Studio, it will show me what I need to send. And then last but not least is that, so this is good for open source, but what about something real like Google Cloud PubSub? Can I use that with Async API? And yes, you can. The answer here is that bindings, Async API has the mechanism of bindings, and cloud providers and other web vendors, they define their own bindings so that you can use their technology within Async API. And I just show you the PubSub one quickly. So in this PubSub sample, you see that I define my server, and then I define my channel, And then under channel, I have this binding, and then Google Cloud pops up. So this is the custom things for the vendor, basically. So I'm saying that, for this channel, I'm going to have a Google Cloud pops up topic, and this is the schema settings and so on and so forth. So by having these bindings, I'm basically defining my Google Cloud topics within Async API, okay? And again, if you take this and paste into Async Studio, you get a nice visualization of what your messages should look like, so on and so forth. So this was an experiment. Basically, as I was learning Async API, I wanted to see what it was capable of. Did it work with CloudEvents? Did it work with Google Cloud? And the answer was yes. So I'm pleasantly surprised. I'm going to use it going forward. And I just want to share with you what I learned. As I mentioned, the slide is here in speaker deck. And if you want to look at these samples, I don't show you many samples, but if you want to look at more samples, I have 2 repos, CloudEvents Basics and Async API Basics. So yeah, thanks very much for listening. We have 5 minutes for questions. So if you have any questions, I'll be happy to take them. Thank you. The code that I was showing was which one? No, that was YAML. So everything I showed, Async API definitions and everything is in YAML. Yeah. No, the definitions are always in YAML. So the definitions are always YAML, but then from that definition, you can generate code in Java. There's actually, if you go to the generators repo, there's different generators for different languages, and 2 of them I think is Java related. One is like a JMS generator, and the other one is a Spring-based generator. You use the Async API generator, point to your definition, and then it generates the code for you. Whether it will work or not is a different question because these generators are open source and community driven. Sometimes I see them being broken because something got updated and they didn't update it, stuff like that. But at least something is there, so maybe it will work. Yeah. Another question? Yeah. Okay, so the question is there anything with authorization and authentication? Yes, there is. I haven't showed it and I haven't actually looked at it in too much detail, but yeah, you can define those rules. And then the second question was, is there anything like Swagger to test it out, you said? I haven't seen it, no, but I'm not totally sure. Maybe, I think I've seen a web vendor using Async API definitions to generate some tools, but it wasn't part of Async API itself. It was just a vendor reading the spec and generating some, I think it was called like micro rocks or something like that, where they read it and they try to generate some code or some containers to test your spec, your services, but nothing part of Async API itself. Yes. Can you repeat that? Right. Well, it's not, I mean, for example, if I take one concrete example, like Google Cloud pops up, the topic is, you create the topic, and then you go to Async API, and then in the channel, you refer to that topic. So that's how you kind of make the connection with the Async API definition and the real thing underneath. But the actual channel, well, the actual channel itself, does it have to have the same name? No, it doesn't have to have the same name. I mean, the channel name is something you kind of define. And then underneath the channel, you point to the real thing, like the topic ID or something like that. That's the way it works. And it's also different from, I mean, it's also different for different vendors. Maybe some vendors, they require the channel ID to match. But in Google Cloud case, you don't need to have the two match. Yeah. Any other questions? Yes. Right. So the question is there any limitations on the number of consumers, producers, or the messages in a definition? Not that I know of, no. I mean, it's a YAML file, so you can put what you want. I guess there's a file limit, right? And also you don't want to put everything in a single file, so you probably want to do something like I showed you, where you have a common definition somewhere. Right. Well, that's more of a question of like what system you're actually using, right? So the async API spec doesn't have any limitation or any of that. But on Google Cloud PubSub, for example, you can have thousands of subscribers and thousands of producers on a single topic. That's not a problem. But on a Kafka running on your computer, there's probably a limit, right? So it really depends what underlying thing you're using to document. Yeah. Anything else? Let me double check quickly the chat. I think there's nothing in the chat. Okay, well, thanks again and enjoy the rest of the conference.